Here's a longest common subsequence table. The number in the corner says the answer is 3. But 3 what? The table gives us a length. It does not give us the string. The actual answer, the letters A, C, E, is hidden inside the path that built this table. Today we learn to walk the table backwards and recover the subsequence itself. Here's the problem. Given two strings, S1 and S2, we want to output one actual longest common subsequence, not just its length. Take S1 equals ABCDE and S2 equals ACE. The longest common subsequence we want to print is ACE. The key inside is this. A length lives in a cell, but the answer lives in the path. Every cell was filled by a decision. To recover the answer, we simply retrace those decisions in reverse. First, we build the full table. Because we need to retrace, we keep every cell. No space optimization here. Now we start at the bottom right corner and walk toward the origin, following 3 simple rules. Rule 1. If the 2 characters match, this letter belongs in our answer. Record it and move diagonally up and left. Rule 2. If they don't match, move in the direction the value came from, toward the larger of the cell above or the cell to the left. And because we collect letters from the end first, we reverse the result at the very end. Let's watch it happen. We begin at the bottom right, comparing E with E. They match. So E joins our answer and we hop diagonally. Now D versus C, a mismatch. We look around. The cell above is larger, so we move up. C versus C, A match. C joins the answer and we hop diagonally again. B versus A, mismatch. The larger neighbor sends us up once more. And finally, A versus A match. Joins the answer and we reach the edge. We collected E, then C, then A, reverse it, and we get ACE. The staircase has revealed the answer. Here is the full implementation. The first loop builds the table exactly as before. Then we start at I equals M, J equals M and walk while both are positive. On a match, we append the character and move diagonally. On a mismatch, we follow the larger neighbor up or left. Finally, reverse the string and return the answer. What does it cost? Building the table is order n times m. The backtrack is only order n plus m. So our time is order n times m. And our space is order n times m because reconstruction needs the entire table. 3 pitfalls to avoid. Don't try to space optimize. Reconstruction needs the whole table. Don't forget the final reverse. You build the answer tail first. And remember, tie breaking on mismatches is arbitrary. Either direction gives a valid answer. There can be several. So here's the one idea to remember. Length lives in a cell. The answer lives in the path. Whenever you'll reconstruct, keep the full table. Next, we add one small twist. Demand the common part be contiguous. A substring, not a subsequence. One change resets everything on a mismatch. See you there.